Bismillah. Hello, welcome back. This class we shall see what is the effect of applying a low pass filter on an image. I have taken a 256 by 256 cameraman image, a grayscale image, and if a 3x3 average filter is applied, you can see that the image is little blurred. If the size of the average filter is increased to 9x9, the image is more blurred. And here a very big 25x25 average filter is applied on the image, and you can see that the image is even more blurred. So now let us see what is a filter, what is meant by masking, and how do we get a blurred object and what is its use. Normally a average filter will be 3x3 average filter will be like this, a 3x3 matrix. The total sum of the values is equal to 9 and it is divided by 9. So this is a 3x3 average filter. And when this filter is applied on the image, all the high frequency components are reduced because averaging takes place. Therefore we get a blurred value. What is a high frequency component? I have taken a simple image. See that if this value is, the pixel value is 157 and this is 156, therefore there is a little change. Therefore this one is basically a low frequency, and likewise 159 to 152 the change is very small. Suppose if this value is equal to 155 and then another value is equal to 255, that means there is a higher change. Therefore it is basically a high frequency component. Right. What basically a masking is? This is a 3x3 image I have taken. Let me take it. I have taken this image. Right, this is my image, and this one is an average filter of 3x3. If 1 is divided by 9, I get 0.111. Okay, now this one is my mask, and this mask is applied over the image. That is, the elements which are below this mask, that is 156, 160, 156. Likewise, this 159, 154, 159. Then the third column 159, 158, 158. The corresponding values are multiplied by these mask elements and they are added, and the final value is replaced at the position of 159. Then this mask is shifted to the left, and again the elements which are below this mask, they are multiplied and added, and it is replaced at 159. Likewise, this 3x3 matrix is multiplied with this 3x3 matrix, and the final value is put there. Likewise, this mask is applied over the entire image like this. It keeps on shifting, and then again it keeps on to the next row, and again it keeps on shifting, and all the corresponding elements which are in the matrix and which are in the mask, they are multiplied, and the final resultant value is replaced at each matrix position. Okay, this is called as applying the mask over the image, and this process of applying is called as the filtering. Okay, since these values, the higher values are reduced by means of averaging, we get a low pass. The higher edges, the high values are reduced to low frequency components. I will show that. Okay, so this I close it, and now let us see what happens when we proceed. Now let us take, I have taken an image, cameraman Dept. Therefore IM is my 256 by 256 unsigned integer value. Let me show the figure. So this is my original image, which I have given the title is equal to original image. Let us take a mask. The mask is equal to f special of average. Therefore my mask value, I can print the value mask. Therefore this is 1.1111. that is 1 is divided by 9 throughout the values. by default I get a 3 cross 3 image. Suppose if I want to see in a rational format, then you can see that this is 1 divided by 9 is common, and this is a 3 1 cross 1 matrix, 3 cross 3 matrix with all elements being is equal to 1. Right, I got a mask. Now if I apply this one, if I apply this mask and say this, if I, yes, once my mask is get, I take im1 is equal to, I apply this mask, the average mask on the image, therefore I get the new image im1. Let us see that image. See that if I compare the two images, this is my original image and this is the image what I get after applying a 3 cross 3 filtering. Here itself you can notice that here the images, the edges are very sharp, whereas here the edges are little blurred. That is, all these high frequency components are being blurred. Right, now let us see what happens when we apply the 9 cross 9. Therefore I have taken a 9 cross 9 matrix. 9 cross 9 81, therefore this is a 9 cross 9 average matrix. And now if I apply this one and if I see this image, see that if I apply this 9 cross 9 image, after applying the 9 cross 9 filtering, you can see that the image is even more blurred. You can compare the original image and the image after making a 9 cross 9 filter. Here the face and other things are looks very sharp, whereas here they are little more blurred. Right, now let us see the effect of what happens when I apply a 25 cross 25 average filter. So this is my 25 cross 25, therefore each element is divided by 625, and I take the image and now I apply this mask 25 cross 25 average filter on the image and I get image 1. And now let us see that image. See that this one is even more blurred. So now let us compare this one. This is the original image, and let us see this one. This is after applying a 9 cross 9 filtering, and this one is after applying a 25 cross 25 filtering. So it is very clearly seen that the larger the size of the mask, the more blurring you get. The larger the size of the average mask, the more blurring you have. 9 cross 9 you have little blurring, and 25 cross 25 it is very hard to find what the figure is. Then from these two figures you can find that here at the edges you can find these values are they are almost in the border they are black, whereas in the original image it is not so. Why is it so? This one it is black because when we apply the mask over the image, we assume that all the values which are outside the mask we treat it as 0, therefore naturally the final value becomes approximately 0, and 0 corresponds to black. Therefore here we get a border, it is of a black color. Alright, so why we use blurring? We use blurring so that we can avoid these high frequency components. Therefore we understand two things: larger the size of the average filter, more the blurring is. Basically what a blurring is: the blurring image normally we get because of the camera's lens is out of focus. Why should we blur an image? To minimize the noise. What is meant by a noise? Noise are the high frequency components. Okay, when we blur, what happens? We are essentially low pass filtering and we eliminate the high frequency content. I told you what is a high frequency and low frequency content. A simple example, a blind example we can take. For example, if the value of one value is equal to say 12 and another pixel value is equal to 34, see that there is a little change. So this one, otherwise even you can take this one equal to 13 and another value equal to say 14 and the other value is 11. So that here see that there is a little change in the value. 12 to 13, a very little change is there. 13 to 14, a little change is there. 14 to 11, comparatively little change is there. Therefore, these are called as the low frequency components. For instance, after 11, if I get this one equal to 200, and after 200 I get this one is equal to 11, and likewise I get again this one equal to 230, and likewise this value, next value is equal to say 0.5. Now here see that from 11 to 200 there is a high change, there is a peak change, there is a very vast change between these two pixels. Therefore this one is called as a high frequency component. Likewise 200 to 11, here also a very major change is there. This is also a high frequency component. 11 to 230, there is a major change, there is a change is very enormous. Therefore this is a high frequency component. 230 to 5, this is also a very big change is there. Therefore this is also a high frequency component. If I take the value 7, between 5 and 7 the values are very less, very comparatively very small changes there. Therefore 5 to 7 is a low frequency, and 230 to 5 is a very high frequency. 11 to 230 is high frequency. 200 to 11 is high frequency. 11 to 200 is high frequency. 14 to 11 is low frequency, and this is also low frequency. 12 to 13 is low frequency. Therefore almost this 11 to 200, this may be there is a spike, major change between this pixel and this pixel. That means there may be an edge, or there may be a quite a difference between in the image, which may be an edge, or which may be a background change and other things. Therefore high frequency contents are nothing but the edges, and when we are making low pass filtering, we are only filtering these values and we avoid this one. Likewise when we say high frequency filtering means we take only these filters where there is a major change and we eliminate these things. Okay, so likewise in the next lecture I will give a simple example of what is a low frequency and what is meant by a high frequency. Here by average filtering, what you have done, you have reduced the edges, you have eliminated the edges, all the high frequency components are eliminated. Therefore basically an average filter is nothing but it is a low pass filter. Therefore here you can see that basically in this one, when you blur, basically it is a low pass filter. We eliminate the high frequency content, that is the edges and other things are eliminated. Alright, so in a nutshell we can say that an average filter is basically a low pass filter which allows all the low changes images and which blurs the images. More the size of the filter, more blurring. Larger the size of the filter, more blurring it would occur. So this is a simple exercise where we have taken three types of filters, a 3x3, a 9x9 and 25x25, applied on an image, and we see what is the effect. Right, the remaining in the next class we shall see what is a high pass filter and how we can detect the major changes, the high frequency, which are nothing but the edges. We shall see in the next class. Right, thank you so much, and please do comment on the video. Your criticism will help me to improve. Thank you so much.